Before I get started, I've also, like Chris and the rest of the team, have led a very outstanding team of folks that's put these POD missions together, and I really compliment them and appreciate their help. Also, Doug mentioned this morning of where the Flagship Center Planning Organization is. It's here at JSC, led by Lori Hansen. And you're right, these lights are, is it Lori out there? Yeah, from JSC. And then Pepper Phillips. Is Pepper in the audience? Yeah, there you are. And both those folks are helping us get this transition, the baton passed into getting a really good transition and get the program or the planning set up, so hopefully in the first of the fiscal year we can kick it off. I'll be talking a little bit of the overview, our interfaces in the flagships today, the point of departure missions, and the next steps, and then have a good summary. Okay, what are flagships demonstrations? If you remember Doug's early chart, we're on the end of the TRL scale, 5 to 6, of that technology which, if demonstrated correctly, will give us a good capability on orbit that we could pick up and actually use to design the exploration vehicles. There are large-scale demonstrations of this technology, and it will improve the capability and reduce the cost of the future exploration missions. There were guiding principles that we worked to when we set up the team. The first was that the projected time, lifetime was no longer than 5 years from initiation to the start. It's nice to have a good hard start and a good end point. The cost was going to be somewhere between $400 million and $1 billion mission set. The first in-space demo we were targeting for 2014 timeframe. We want to encourage international, commercial, and other government agencies to partner and with us. And then no single NASA center will have each project. The projects will be spread across the centers. And we're working right now on the assignments to where these go. So our task when we got started was to develop the long-term roadmaps and approaches for the near term. We went through an evaluation of the highest leverage demonstrations. We were using Mars as our driving case. If you remember the swoosh chart that Doug presented, those were our driving cases that gets the mass down, and if we can be working on those technologies in this next 5 to 7 years, we can get a good bang for our buck and actually get to where we want to. So of the technologies, we have the in-orbit propellant transfer and storage for long periods of time. I'll get in a little bit more in the technologies at least. Lightweight inflatable modules. Automated autonomous rendezvous and docking. This is taking it where you can actually get the human completely out of the loop. Aero Assist, entry, descent, and landing. Closed loop life support. And then the advanced in-space propulsion, and that's ion or plasma engines. We looked at, as we were going through the studies, identifying potential partnerships with industry, other agencies, international partners, academia, leverage on some of the ISS technology demonstrations as appropriate. And based on that, once we packaged everything together, set up our needs, goals, and objectives from all this, we came in with 4 missions that would demonstrate those 6 technologies. The solar electric propulsion, along with an ARND demonstration, propellant storage and transfer demonstration, again with some ARND associated with it, inflatable module that would be delivered to space station, and also later on have a closed loop life support system included, and then the Aero entry, descent, and landing missions. Where we fit in the big scheme of things, you have the Flagship Technology Demonstrations, you have the projects that are down along the bottom there, but we end up working with, as I said, academia, industry, DOD, other government agencies, internationals, of course, all the directors within NASA. We're hoping to have an engineering steering committee that would drive the requirements, working with the Office of Chief Technology, and then a mission analysis and planning office that as these requirements came in, when the technology is ready at that 4 to 6 level, we would be able to craft a mission around it and then generate a future mission. So these first 4 are just the ones that get us out of the gate. We're planning, as the time goes through and as budget allows, to be able to generate and produce new missions to develop additional technologies. So we're just not stopping here. Okay, for the first flight mission is a solar electric in-space propulsion demonstration. We're shooting to go from right now we're around 3 kW capability in space, and we're going to be working toward a 30 kilowatt demonstration for the first one out. Eventually, if you go up the roadmap, and I'll show that on the next chart, we'll be able to move up the power and actually include possibly Vasimir or plasma kind of engines and more array technology and higher power. There's applications here for delivering cargo within low Earth orbit. Robotic operations, I think the robotic operations folks are looking at using the solar electric propulsion technologies. DoD for Earth space operational missions, and of course commercial vehicles for orbital transfer vehicles, servicing missions, and then debris removal. There are potential partnerships with DoD and commercials in this area that we'll be investigating, and the other aspects where this is hopefully be our first one out of the gate, launching in 2014 with a 2-year mission duration, and there are going to be secondary payload opportunities on board. The roadmap that follows, I talked about a little bit, is that, again, being at the 3 kilowatt levels right now is state of the art. We want to move up to the 30, and then as you see, as you grow up, and eventually there's actually, if we did the roadmap properly, you would break off and be able to use other technologies for your power systems possibly, which is now in the foundation work that Chris was talking earlier today, but would eventually could be land on the roadmap here. In the array activity, you could see the space station we use as a reference point on the solar array, and then with the new fast array systems, the small, it's really hard to see on the corner of the wing there is how much array material is actually used. So you get a very good bang for the buck, an order of magnitude over the space station technology. For the second mission that we pulled together is a cryogenic propellant storage and transfer mission, cryostat. It's basically, right now our mission analysis was using LOX methane, again based on Chris's early work as far as an upper stage. If we were on a methane economy, both oxygen and methane, is relatively easier to store in space. The technology readiness was there, so we used that as our baseline. With the RFI that's out, we're actually investigating, would like to get some suggestions back in on possible hydrogen LOX and hydrogen LH2 to see how that would fit in a mission scenario. There's an ARND demonstration possibility as part of this, that you would come up and dock, possibly make the QDs and be able to transfer propellant across. Or if we don't end up doing the ARND portion of it, we would end up just transferring fuel within the vehicle itself. So we're looking at both options. And in the RFI that we released last week, we would solicit ideas around that also. The long duration storage, we're looking for around 200 days. Launch would be 2015. And again, there would be secondary payload opportunities on board there for either exploration technologies or science. We follow the roadmap. This would not be the first one that we would envision for a flagship. We would start with a single bus vehicle, and then in the later 2019 timeframe, 2018 timeframe, we may generate another one that had multiple fuel tanks that we could actually put together and start putting a depot approach together. On the inflatable mission module, the technology work started around 1999-2000 for JSC. This has proven through our design analysis that you get a lot of volume for a lot less mass. And so the objective of this particular mission is to deliver an inflatable module, not as large, if you remember the Transhab, but a much scaled down version, but enough that you could actually put a closed loop life support on board and actually get some crew operation inside of it. Deliver it and inflate it and get some long-term operations on board. This would enable us to get the confidence in the technology necessary to be able to actually make an exploration habitat out of it for departing low Earth orbit. We're going to be working MMOD, thermal. In addition, there were some comments made about the radiation protection. Using some of the materials that might go on board could be used for looking at the radiation. Again, you're not out in the GCR range, but you could get some testing on materials for that. There's orbital science, industrial modules, and possibilities on this. Of course, the spacecraft is inflatable and be good for long duration transport of crew. There's a good commercial, international, and academia interest in this, the way we understand it. We're shooting for launching the inflatable in the 2015 time frame, and then later on, about 1 or 2 years later, delivering a closed-loop life support system on board. And again, there's secondary payload opportunities. The roadmap, we started with possibly a little bit earlier, and we're working with Space Station on this, is a small structural test article that could be delivered to station. No agreement's been made yet on this, but there is a possibility of bringing this to reality to get some early runtime on an inflatable that wouldn't have any systems on board, but it would basically check out the technology and the structural pieces of it. Then as we move into the 2015 timeframe, we would launch the inflatable and then bring the closed-loop life support on board. Part of you see the EMU at the end, because of the design of the materials, we're looking at possibly putting a suit port where you can actually put the suit out external, and the crew would go through the suit port and be able to generate an EVA directly out of it. So there's some possibilities that could come about. This is another chart showing the closed-loop life support. There's 3 bands, or actually 4, that gets us to the final closed-loop system. We have some technology development and maturation that would be under Chris's program, EDTD. Then we would build a ground-based demonstration to get a long-term runtime on it, be taking component technology up to ISS for utilization, and again, the end game would be to have a closed-loop life support system that was an exploration-ready system that we could get some runtime and get some confidence in. The last demonstration is Earth or Mars-based Aero Assist demonstration, and we're still looking at the studies on whether we want to do a Earth base at high altitude, where we could recover the materials once we do the reentry work, or we go ahead and take it to Mars and try to put some payload on board on the surface of Mars. The launch time around that is around 2016. We're looking at the launch window for Mars, so we can make the choice then, and then have the second one in the 2018 time frame. We're looking at inflatables or hard shell reentry vehicles. The goal is to take the current landed mass at Mars, which is around 1 metric ton, for this end of these flagships to be around 10 metric ton, and have some landing accuracies, put the sensors on board to get the accuracies for landing within 1 kilometer of where your target is. And again, there's potential partnerships both across the gambit, international industry and commercial providers. Here's the roadmap. Right now there's IRVI 1, or I guess it's IRVI 3 and 4, which are sounding rocket tests that are on the books to demonstrate, and then we would move forward and start developing based on the lessons there and some of the early technology development to get into the inflatable or the TPS materials for the hard shell. Eventually in the 2022 to past 2020, actually putting something on the surface and landing fairly sizable masses on the surface of Mars. Now, one of the common themes is the ARND vehicle. The way we laid out the approach was to use the solar electric propulsion and put an ARND vehicle to do some early testing on some of the ARND algorithms and sensors. The next one would be the tanker, or the cryostat vehicle would also have a potential bus that could rendezvous and dock and transfer fuel to. And then finally the ARND activity for delivering the inflatable to the station. Because of the OERM or the CRV, the addition, we're looking at whether it would be better to demonstrate that technology there. You're still going to have some delivery vehicle for the inflatable, but those are all in the trade space right now. And you could see all the different purviews of the folks that have been working ARND. And again, the goal of this particular technology development is to take the human out of the loop and have a totally automated system. And so there's a lot of trade that's going to have to go on through the next months to actually work that out and get it integrated with the return vehicle. Okay, and the elements we have for the ARND, of course, you have the mission manager, you have your sensors, GNC, and the docking mechanism, which right now we'll be relying on the international docking standards. In each of these missions, we started with FTD 1, 2, and 3. We advanced to get the loop closed a little bit further and further. So at the end of the FTD 3, we would actually have an ARND capability for anywhere in the solar system. People can't see this, but probably in the back, but this was just as we stepped through and increased the functionality. Tomorrow at our FTD plenary, we'll be able to go in more detail with this for the folks that are interested in answering some more questions. But it does show the progression of each of the technologies leading up to the final flight. Okay, the next steps where we're working is the RFI was released last week. I've had talked to some people today about it. In the June-July timeframe, we'll be receiving the inputs and then synthesizing those through and to take the inputs into your good ideas and finalize the mission set. And again, we are open to modifying our point of departure because of the amount of time we spent. We needed to, now was the time to go solicit the ideas from y'all to try to come up with the best way to economically and efficiently demonstrate this technology. During the June and July timeframe also, we're updating our budgets and the workforce estimates to provide and get the feedback from the NASA centers that are actually going to be doing the work. We're going to take the RFI inputs and feed that back into the system and actually go through another iteration as soon as we get that put together. Finally, July and August, we'll set up the functional requirements for each of the mission sets, and based on the new mission analysis and planning work that will go on, coming from the RFI synthesis. And then in the August-September timeframe, we'll start defining our procurement strategies and ready the procurement documents, so hopefully the first of the fiscal year will be, if we get the go-ahead, we can actually release them into the system and start putting the mission sets together. Next chart. Oops, I got the clicker, I'm sorry. This is a little bit harder to see, but it kind of walks through what we've been going through. The April 2010 RFI work went out. May, we're collecting the responses, or generating responses, starting to engage the community. The summer is going to be real busy working the budget activities and looking at the different procurement instruments that are possible with the responses from the RFIs we get, and then figure out an acquisition strategy to go get that, lay out the procurements, and then once authorized, release them. So we have 4 reference flagship technology demonstration missions right now that are serving as our point of departure. Your input will really help to help us codify the work we've done and modify it to make it more efficient and more robust. Oops. Did I do that? Nope. Okay. You've already talked about the 6 technologies and the 4 missions. And tomorrow we have a full day starting at 10 o'clock, and we'll go to around 4:30, where the mission advocates for each of the mission will be going through each of the mission sets and be able to answer questions and go in a little more detail than I did today. Today was really a thumbnail to see exactly, to let y'all know exactly the overall program aspects. And then what we'll end up doing is go into details and then answering some of y'all's questions related to the RFI. So this is a nice chart just to show the work that's been done. The engineering work that's been done is based on some real good mission analysis and planning activity that the team's been doing. And before I go to the next one, are there any questions? Okay, we got two hands up there.
Hello? Do you hear me?
Yeah.
Okay. There are some, for the propellant transfer and the, oh, I'm sorry. I'm John Barr from United Launch Alliance.
Uh-huh.
Okay. For the propellant transfer and cryofluid management, there are some pretty logical precursor demos that could come along. I didn't see them on the enabling technology list, so I was wondering, do you, within the flagship, control your own precursors even though they're small dollar value relative to the target? Do you have to convince Chris Moore to put it in enabling technology or get Bobby Braun to put it in his category? How do you handle precursors?
For precursors, that's something that Chris, Bobby, and I will be working out as, and again, if we get suggestions like that back in, we may have to go and add that to the mix of things for precursors. If it doesn't do the whole job, again, we're trying to demonstrate the incapability for doing an expiration time of class, and we wanted to try to buy it a total package, if you would, for the demonstration itself. If there's early things, though, yes, I think I've worked with Chris in other areas where we've actually said we need a little bit of work done in this area before we buy into it.
Phil Spampanato from
Hey,
ILC
Phil.
Dover. You've emphasized, Mike, a lot of international cooperation. I mean, you've kind of said that every other chart here. And in addition to that, these flagship technologies are in the TRL 5, 6 time already, meaning there's a bunch of technology out there that's ready for prime time. Our experience in the ITAR world is that it takes time to be able to work with the internationals, get agreements, technical assistance. Do you guys plan to expedite that, or you already have an expedited process that would allow us to work with somebody and share this technology that's not in the public domain today?
That's a good question. Yes, we are trying to work through, first of all, we need to inventory what the internationals may be. And Kathy Lorini here? She's been helping me out on this one. I guess she's out. The answer is yes, but we need to inventory what the internationals are interested in as far as their cooperation goes, or to start to have a partnership with them. And so how all that plays out with respect to meeting schedules and all, yeah, that's going to all have to be factored in. But I think it's important that there are some things that the internationals can bring to the table that would help us do our job and be able to help us with the expiration and be able to get out of low Earth orbit.
Hey, Mike, I can help you out a
Yeah,
little
okay,
bit there
thanks,
on the
John.
international side. So essentially, it's kind of a portfolio. From an international perspective, we're already working and canvassing through technical interchange meetings that are planned or envisioned for the mid-June timeframe through July. We're also, as you're probably aware of, there's the broader ITAR reform activities going on throughout government. I believe that's Presidential Study Directive 8, and so that is also envisioned as a potential enabler for some of these tech activities. We also have several different mechanisms through comparative architecture assessments as well as TAA activities, and so we'll bring the whole portfolio to bear on that international dialogue. Likewise, there's been some industry-to-industry efforts that have been going on. We're going to bring those up and link those with our government-to-government activities. So. We're looking to create those venues to increase that cross-com. Does that help, Mike?
Yeah, thanks. Any other questions? Let's see. Okay, thank you. I guess, Mike, you're up. Yeah, I think. Whoops, Hey, Derek? Did I push the button? He's driving. What you would have seen would be some really cool videos.